So let's get started. Welcome to How and When to Use Right Angle Heads. I would like to introduce you to today's presenter, Preben Hansen, owner of Platinum Tooling Technologies in Prospect Heights, Illinois. Take it away, Preben.
Thanks, Hope. So I'm going to talk, as Hope said, a little bit about angle heads today. It gives you some maybe some examples of when you might want to use it, how you should use them, how to pick the right one, talk about the questions that would come up in regards to the machines and how to use them in the machines that you have. And then I'm going to end up with a couple other things after the angle heads just to give you something else to think about. The angle heads come in many different sizes and shapes depending on the applications that are required. Very often the tools are used for secondary operations. You might have a workpiece that needs to be refixtured to finish it off. You might have to send it out even to another shop to do some work. Maybe you got to put it on a different machine, and often the addition of an angle head can eliminate those. And thinking about the time and expense to move parts around or send them out, it's sometimes not very difficult to justify the expense of the angle head. Part of it, where you also are going to think about how you're going to use it in the machine. Are you going to run it through the automatic tool changer? Are you going to hand load it? What are the options on that? And I'll go through some of that today. So most of them can be run through the tool changer, but not every machine is consistent in what it can handle, both for weight and size. So it's something that is pretty important to think about right from the beginning. So the angle heads come in a lot of different sizes, as I said, and shapes. The first tool shown, the standard angle head, is by far the most common, and it's used when you really have no constraints or interferences. It's the shortest that you can build it, and because you keep it up short, then it ends up being the most rigid. And it comes in many different sizes as well. You could have a Cat 50 that would output to Cat 40, or even a Cat 40 tool that'll output to ER 25 and only weigh 12 pounds and can tool change on just about any machine. So this is by far the most common. And then the double spindle is used quite frequently as well. As you can see in that application, they're showing slotting inside of a workpiece, but we've seen these used for working on both sides of a workpiece as well. If you have a part on your machine and you need to work the right and the left side, if you have enough travel, then you can use a tool like this and you can get work done on both sides of it. The offset style shown next has an advantage in that it helps you maximize the tool length. It can be used when you have a little bit of constraints, but you need a longer tool. We actually move the output of the collet close to the center line, so you can use as long a tool as possible. And I'm going to give you some examples of why these tools are built the way they are moving forward. The offset slim is the same concept in that it has offset to maximize tool length, but now you have a slim design, and then you add length, and it allows to access some features down deeper inside of a part, or even going inside a tube. But when you have to have some reach, a tool like this is very handy. And then sometimes you need a universal tool because you have an angle, compound angle, where you're trying to get down at a 30 or 45 degree, and then a universal tool can be handy. The drawback on the universal tool is that they're not quite as rigid since you have the ability to adjust it. So you have to take that in mind regarding the application. You know, is it strong enough for it? Or, you know, if you have a production application at a certain angle, maybe you actually need to make a fixed angle tool, and then, you know, it would have the same rigidity as a standard 90-degree tool. There's also many applications for very small hole drilling. You can get, with a tool like this, you can get down inside of a half-inch diameter tube, for example. You need to get close to a wall, then this is the type of tool that'll do that. We've seen these used in the aircraft industry quite a bit, where they're putting holes through walls. But this is a drilling tool, so this is a tool that you're not going to be doing any side milling with, and you're drilling holes maybe 1/8 of an inch maximum. But there's no bearings for side support, so you're only going to drill. But they have extensions. You can reach far down inside of very small parts, and they come in a 45-degree angle as well. So here's an application that where we're using a offset style. As I mentioned earlier, you can see that it's working inside a radius, so it's a little bit harder for the tool to get close up to the wall. So the offset will then allow the cutter to reach where it needs to. And clearly this kind of part is something where it's really requires an angle head to do. It would be very hard to go ahead and finish this part without an angle head. Okay, so many times cutting keyways is a very common use of an angle head. This happens to be a large keyway, 1 inch wide. You can see on the left side of the hole that we're cutting a keyway there, and we're going 15 inches deep into this big die. But keyways come in all sizes and shapes, and their angle heads are you know, fit this application very well. Cutting slots inside of a workpiece is another pretty good example for where an angle head's used, and this is also a good example to show on how to evaluate what you need to do. We took a solid model of the workpiece, and we took a solid model of the angle head, and put the two of them together to evaluate that and could in fact finish the job and do everything complete. We needed to confirm that the cutters needed to be 55 millimeters long, and the angle head would fit, and you could use those. And by taking a model of the angle head, the model of the part, all of this could be figured out beforehand. So it's part of the evaluation process, and a good thing to look at if there's any questions or restraints that we need to consider. So 3D modeling today is very common, and you know, a lot of you guys will have the system to do it yourself, but if not, you know, we're able to as well. So here's an example of a extended reach tool, the slim offset, and how you would be able to reach down inside of a workpiece and do some cleanup work. This tool is in a very large casting, and it's finishing off some surfaces that need to be machined inside. Another application where it would be very difficult to do without having an angle head. So the tool we just looked at also had a changing system built on to it, and this is something that probably should be thought about pretty hard when you're looking at an angle head. You know, is the output, do you want some flexibility on the output? The video we just watched had a small face mill on, and they were using an adapter similar to what's shown on this slide here. Or you might have an application where you'd want to drill and tap with the same angle head rather than buy two angle heads. So then you could have a tool where you would have multiple inserts, and you'd have one insert where you'd have a drill, you'd have another insert with a tap, put a cycle stop in part way after the drill, change the insert in, press go again, and then run your tap in. So the flexibility is something that is probably good to think about long term, because you have a tool like this, it can do a lot for you if you have the ability to have a little flexibility with it. So once you've decided on the angle head that you're going to use, you need to take a look at the machine and see how are we going to connect it to the machine. And that is done through the torque arm and stop block that's highlighted here. The stop block gets attached to the machine spindle face several different ways, and I'll go through some options on that. And then the torque arm which is sometimes called an anti-rotation device, but the torque arm is engaged in the stop block whenever the tool goes into the spindle face and does a couple things for you. The torque arm orientates the angle head in relationship to tool change, so you can use an automatic tool changer doing it. And it also has a spring-loaded release on it, so when it's engaged in the stop block, the pin is pushed down and the angle head is now free to rotate. So you got to figure out how to hook a stop block up to the machine. And this is one typical example. It's not how they're all done, but here's a case where the spindle face actually had nowhere to put the stop block on, so we had to go back to the quill and attach a long block and make an extended stop block that would reach down and connect with the torque arm. So, but not all machines are difficult to do. Some are very simple, and for example, on a Haas machine, a Haas spindle face already has the holes for the stop block drilled and tapped. You screw the stop block in, you put the machine in, the angle head in the spindle face, tighten everything up, and you're ready to go. And then you have a tool that can run through the tool changer. So even if you're hand loading it, you do need to have some kind of stop block anti-rotation device on there, but it's important for holding the tool. Occasionally, you will also run into a situation where maybe the angle head does not fit through the tool changer. It could be too heavy, it could be too big. There's limitations. But you also don't want to hand load it because you don't want to take the time to stop and put that in. You then can build something like we have shown here, which is a cradle to hold the angle head. The left side is the angle head sitting in the cradle, and then the right side is after the machine's picked up the angle head and put it in position to start working on a fixture or a workpiece that's held in a fixture there. So there is ways to do it, and here's a short video showing you how that works. So most machines you can program in to come over, release the pull stud gripping mechanism, come in, pick that up, and start to work on it. So you'll also notice on this tool there that it has 3-pin support holding it in position to add stability. And that's part of the reason it's difficult to use a tool changer. When you need a little more support for the tool, the automatic tool changer doesn't have space to run it. And this is what that tool has. It's called a 3-pin support. The support adds stability to the angle head. If you think about an angle head and you're sticking maybe 10, 8, 10, 12 inches off the spindle face, and you're trying to machine down that far away with a tool that has small gears and small bearings in, sometimes little extra stability can really help the process, and that's what this does. The 3 pins are produced so they apply a small amount of preload directly onto the spindle face, and then that preload makes the whole angle head much more stable during the machining process, and it really helps for a lot of parts of it. It helps your finish be improved. It helps you be able to use the tool a little bit more. And then there's occasions where even the 3-pin support is not enough, and you need a big tool. And you know, for example, the tool on the left side, that's a 50 taper tool with a 50 taper output. So the tool probably weighs 100 pounds, and you know, just holding it by the 50 taper or the 3-pin support's not going to do it. So in this case, the machine builder supplied a gear, which is the Herth coupling, and the tool matches up with the Herth coupling, so there's no movement at all on it. This tool is also a internal coolant tool, so it's possible to run coolant through the pull stud all the way down into the 50 taper output on it. So sometimes you need this kind of accuracy and rigidity. The tool on the right is another example of big tools where in this case you actually are bolting the tool right to the spindle face. So it's a semi-permanent setup, and it can come on and off, but you know, the tool shown here, for example, is maybe 35, 40 inches long and with a ER40 output, and so you're holding a 1-inch tool 40 inches off the machine face. There's only one way to do that, and that's to bolt this onto the machine. This is for getting into big parts and machining in very tough to reach places. It also shows you a couple other coolant scenarios here. In this case, there was coolant through the spindle was not possible, but the tool will have a couple coolant ports where it can direct the coolant down to where the cutting tool is. And then many times a standard off-the-shelf angle head is not appropriate for the application, and you're going to need to build a custom tool. And I got some examples of the custom tools here for everyone to see. This particular tool is for machining inside pump housing. So the stand on the left is a display stand, but it shows the tool in housing that's cut out, and it shows a cutter that's coming down to machine the bearing seats inside this housing. So this was developed based on a 3D model as well. Here's a tool that was built to reach inside of a long bore. You know, this was a tool that probably goes 12 inches, 13 inches inside of a 2-inch bore, and can do a little bit of machining down inside. You're not going to hold a big tool in case like that. It's probably a 1/4-inch tool, maybe max, that'll fit in there, but it's something that can be done. You can see the picture on the left side. This is also a tool where the 3-pin support is used. So something where you reach out that far and go down that long, the added stability is definitely a big part of making a tool like that work. You know, this is a tool that was built for a custom machine. They're doing line boring for cylinder heads and engine building. You have two arbor outputs 180 degrees apart, and they're actually holding boring tools on there. So it's about a 3-inch diameter boring tool, so that this tool, and it also has a custom connection to the machine. So there's not a lot of limitations for what you can do. Here's a couple really big tools. These are 100-pound tools. HSK 100A is a big taper. These also have the 3-pin support, 1.25 inch output, so to do some really heavy duty milling on it. So in recap on the angle heads, there's a few things that you all need to keep in mind together. You know, what kind of application specifically, what material are you cutting, your finish requirements. You got to understand there's gears inside of this, there's bearings, so you got to be careful about that. What machine is it going on? Can the machine handle what you want to do? Will it handle the tool change options, the weight restrictions, size, all of that? So it all plays a part when you're making a decision on an angle head. So, and then I have a couple other tools that, since we're talking about machining centers, I thought might be interesting to throw in the mix here. Sometimes machining centers need a little more speed. So spindle speeders are something that can be used in a machine as well. This particular one shows a geared tool that runs up to 50,000 RPM. It'll multiply the spindle RPM on the machine by 7.7 times, and has internal coolant capabilities, and I just have 50,000 RPMs. A lot of times a tool like this will help increase your machine spindle life. It means you don't have to max out the spindle on your machine if you can put a speeder on there. Or a tool like this is a little bit bigger. It's a 30,000 RPM tool, but you know, you can hold a 5/8 cutter on it. You know, and again, you know, if you're running your machine spindle at 100%, sometimes the heat generation, sometimes the life of the machine spindle will be shortened, and putting a speeder in can help that situation be easier on your machine, and many times can justify the cost of speeder just in the fact that the machine spindle is going to last a lot longer. Sometimes you need to run continuously, and you know, air is the answer for that. Geared tools have a duty cycle on them, and they have a limit to how long you can run them at their max RPM, but air tools do not. They can run continuously at 50 or 80,000 RPM, and they're great for engraving jobs, small light milling in aluminum, and there's really no limit to how long you can keep running these tools. And then the next step up would be a motor spindle if you really need a consistent, high torque, vibration-free spindle to supplement your machine. These can be mounted near the machine spindle on the side of the machine, and you can get 80,000 RPMs. You can get these tools that are have tool changeable cutting tools on there, or tool changers. Something like a small HSK tool can go on the end of these, and they run totally independent of the machine. And here's an example of a air speeder running in an aluminum. So this is running at 60,000 RPM, and you know, moves pretty quickly this way. So a machining center could even be used for cutting splines or gears. These are a couple examples of tools that were built for doing spline cutting. The tools have an arbor output, and that arbor has bearing supports on both sides, and that's where the spline cutting tool would be mounted. So you can, you know, actually cut a gear or a spline or, you know, teeth of various size by using a machining center tool like this. Again, a 3-pin support is shown on this for the stability that you would need. And then a machining center can even be used for drilling with a multiple spindle drill head. If you have an application where you use the same hole pattern frequently and want to get away from doing one hole at a time, a tool like this where you can do 4 or 5 holes at one time can also be justified by the time savings that it gives you. So multiple spindle tools, they come into play as well. So that's what I have for today, and I thank you all very much for listening to me, and if there's any questions, I'd be happy to answer them.
Okay, well, thank you very much, Preben. We do have one question so far. Terry is asking, would the u-tec connection option be more or less rigid?
It's a very rigid setup because it actually has the taper of the ER and a drive in the back, a little polygon drive. So to answer, you do not lose anything in rigidity by adding that connection. It's a very solid setup.
So we do have one more question here. Richard is asking, I'm with a company that is involved primarily with heat sinks, chill plates, etc. A lot of our heat sinks are extrusions, but we also do a fair number of custom heat sinks using aluminum plates and aluminum sheet metal fins. Currently, we have to mill or use a slitting saw one slot at a time. Some of these bonded fin heat sinks have around 100 fins and thus having to slot 100 slots or more. Any right angle head attachments that would be good for milling and cutting multiple slots at once?
That's a really good question, and in fact, we have done an application like that. And if we used a tool similar to the gear hobbing tools that I showed at the end, multiple saws can be added onto an arbor like that. So depending on how far apart the saws need to be, yeah, you can do you can have a lot of saws mounted and cut many slots at once. So it is possible, and I'd be happy to look at that application and come up with some kind of concept if you wanted to pass along some data to us to look at. We could design something for it.
Okay, great, thank you.
Okay.
Bill is asking, what's the duty cycle suggestion for a lathe BMT65 live tool?
A duty cycle on that would probably be somewhere in the neighborhood of 20%. So in other words, it's 20% at 100% of the RPM. So as the RPM goes down, you can run it longer, but it would be, for example, 2 minutes out of a 10-minute cycle time. You could run the tool at 100% of its RPM. But if you ran it at 80%, then of its RPM, then you could run it a longer duty cycle. Then it might be 60% duty cycle, as an example. A little bit depends on the application and what exactly you're doing, drilling, milling, but max RPM 20% is a good estimate to look at.
Okay, it looks like that's all the questions we have. And again, if you have questions following the webinar, feel free to share them with us and we will make sure you get your answers. So I'd like to say thank you to today's presenter, Preben Hansen, Platinum Tooling Technologies. We also thank all of you for taking the time to join us today. We hope you enjoyed today's webinar and look forward to seeing you again soon. Until next time, stay safe, stay healthy, and thank you for your business.